All right, this is part 2 of the Algebra Chapter 10 practice test. This says describe the transformations from the graph of f to the graph of h. Well, f looks like the parent graph or parent function, the square root function, and h obviously is different. I always say to list these based off of if you are x, what's the first operation that's done to you? You have the added 2. And so that's going to be the first transformation, and that's a horizontal translation. And it's going to be left 2. Wow. Okay, next one is going to be, you get multiplied by negative 7/3. I usually do sine first, so that's a reflection in x-axis. And then you multiply that by 7/3, so that's a vertical stretch because it's outside the function. And then by a factor of, I'm going to not use proper grammar, factor, sorry about that, of 7/3. And then finally, the last one is a vertical translation, down 5. Okay, hopefully you remember that. We've done so many of those this year with all the different functions that we've looked at. So at this point, hopefully it's starting to get just automatic that you recognize what each of those different numbers does to the function, a, h, and k. Okay, solve the equation and check your solution. Cool. Well, we have 3 times the square root of x minus 5 is equal to 27. Whenever we are solving an equation with a square root that has the variable in it, we first want to get that square root by itself as best we can. We divide both sides by 3, and I get the square root of x minus 5 is equal to 9. Now I'm going to square both sides. And when I square both sides, I'm going to show it because this is the new step this time around. I have to be careful, and I'll particularly explain why number 10, but I have to be careful when this happens. This is like using the squaring property of equality, which isn't a thing, but if you square both sides, they should be the same quantity. So I get x minus 5 equals 81. I add 5 to both sides, I get x equals 86. And I'm just going to do a verbal check on this. If 86 is substituted in for x, 86 minus 5 is 81. The square root of 81, the principal square root anyway, is 9. 9 times 3 is 27. So we know that x is equal to 86. Okay, same goes for a cube root function. What you want to do is subtract 3 from both sides to get that cube root as by itself as possible. That's supposed to be a 4. And then you can cube both sides, right? Because if you cube both sides, you should get the same quantity on each side. So I'm writing over the equal sign there. And I get x equals, and then 4 cubed is 64. And then, of course, we can check that. I shouldn't have boxed it. I should wait to box it until after I check. But OK, cube root of 64 is 4 plus 3 is 7. So we know that that's correct. Okay, this next one's a little bit different. When we were squaring both sides on number 8, we squared the side with the square root, and the opposite side of the equation was a number. So when we squared that, it's just 81. The thing is, on this one, if I square both sides of this, the right side is a variable. And that can be dangerous because a variable, like for instance, let's say k squared ends up equaling 81. Well, there are 2 different values for k that can be squared to equal 81, 9 and negative 9. So this can cause problems. We can end up getting solutions that aren't actually solutions. We'll have to check at the end, but just be careful. I would just always check any solution you get doing this to make sure you don't end up forgetting or accidentally saying, yeah, this is a solution when it's not. Okay, here's what we have, a k and a k squared in 2 different terms of the equation. Hopefully you remember that if that's the case, we should write this as a quadratic equation. That means in the form ax squared plus bx plus c equals 0. I want the k squared to stay positive because I know how important it is to have a positive a, especially if you're completing the square. It can make your life a lot easier when you're factoring. It can make your life a lot easier. So I'm going to keep the k squared on this side. I'm going to subtract 10k and I'm going to add 21 to both sides. And that way I get ax squared plus bx plus c equals 0. This is a quadratic equation. I can solve that in numerous ways. One of them is to factor and then use zero product property. That's using like the x method. Another is to complete the square, which I can because a is equal to 1. And another is to use the quadratic formula, which I'm sure you're all super stoked on. I'm going to try factoring it because it looks like it's factorable. These numbers are nice and small and pretty easy. So I'm going to make my x. A is 1, c is 21, so that's 21. And then basement, negative 10. And so I need two factors of 21, which are also add-ins of negative 10, and that's negative 7 and negative 3. Negative 7 times negative 3 is positive 21. Negative 7 minus 3 is negative 10. Technically, I put these over a, which is 1, but there's no way these fractions are going to reduce. So this gives me 0 equals k minus 7 times the quantity k minus 3. Okay. All right, so now I have a factor times a factor equals 0. I can set each of those factors equal to 0 using the zero product property. You know what, I should have said, if you use FOIL on this, verify that it's k squared minus 10x plus 21. K squared first, outers negative 3k, inners negative 7k, it's negative 10k. I don't know why I put x there. That should be a k. And then negative 7 times negative 3 is positive 21. Okay, anyway, k is equal to 7 and k is equal to 3. Now, before we say these are actually solutions, we have to substitute them back in. I'll use 3. If I substitute 3 and I get negative 21 plus 30, that's 9. The square root of 9 is 3, which is also 3 here. So that worked. 7, we box it to say, yep, that's a solution. 7, 10 times 7 is 70. Negative 21 plus 70 is 49. The square root of 49 is 7. And that, of course, is also k, which is 7. So it looks like they're both solutions. I can write k equals 3 and k equals 7. All right, number 11, we have square roots on both sides. That should be fun. Same thing, we can square both sides, but we might introduce extraneous solutions, ones which aren't actually true. And that leaves me, I'm going to move this over so I don't get it mixed up in here. 5p over 6 is equal to 3.5p minus 24. I multiply both sides by 6. At least that's what I'm going to do. And so you get 6 times 3.5. You know, I should show this because a lot of people end up not seeing it. Whenever you multiply both sides of an equation by the same number, you have to multiply all of the terms by that same number because you're multiplying this whole quantity. So you get 5p is equal to 6 times 3.5 is 21. Minus 6 times 24 is the same as 6 times 25, which is 150, minus 6, which is 144. I'm going to switcheroo all of this. I'm going to add 144 to both sides and subtract 5p from both sides. And I get 144 is equal to 16p. Divide both sides by 16, and then p is equal to 9, because if it was 16 times 10, it'd be 160. So you have one less group of 16 to get to 144. Okay, if p is 9, you would substitute this back in. 5 times 9 is 45, divided by 6, 7.5. So this would be the square root of 7.5. And so we should get the square root of 7.5 over here. 3.5 times 9, that's 30, is that right? 631.5? And then, yeah, it is, because then you subtract 24 and you get square root of 7.5. Yeah, so that worked. So it must be p equals 9. I should box it, huh? Just to like really make sure. Cool. I'm going to end this video here so that I can do the last 2 questions on a third part, so that my computer doesn't crash, because right now I'm trying to quit the program and it won't let me. Yeah.